In this video, I'd like to talk about the math question of the day for Wednesday, April 26th, 2023. And with this problem, we need to calculate the distance between these two coordinate points. And to answer a question like this, you will need the tools of geometry, since that is typically when a topic like this is taught. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, when finding the distance between 2 points, there are two main approaches. One is that we can use the distance formula, where d, the distance between the 2 points, is the square root of the difference between the x values, we can call those x2 and x1 squared, plus the difference between the y values, which we can call y2 and y1 squared. And this is for two coordinate points, x1 comma y1 and x2 comma y2. So if we label which ones are x1 and x2 and which are y1 and y2, we just plug them into this formula and we can find the distance between the points. And you might wonder where this formula comes from, and that's really the second approach. That second approach is that we can plot these 2 points, which, let me very quickly draw a coordinate plane. And if we plot these 2 points, we can connect them with a line and find the length of that line using the Pythagorean theorem. So let's start by plotting this point right here, minus 6 comma 4 in green here. So we go left 6 units and then up 4 units, so it should be right about there. And we can do this other one in this orange color here. We go to the right 5 units and then up 1. And we want to find the distance between them, so let's connect them with a straight line. And like I mentioned, we can use the Pythagorean theorem, since we can deconstruct this into a right triangle. If we drop a vertical line here and construct a horizontal line going over to this point here. Now, I didn't draw that perfectly, so let me redo that. We have this right triangle where the height of the triangle, this vertical component, is just the difference between the y values. We have a y value of 4 here and a y value of 1 here, so this height here will be 3. And this horizontal component, we notice that this has an x value of minus 6. This goes to positive 5, so this length right here would just be the difference of these values, which is 11. And if we call the length of this line here the distance between the 2 points, we can call that d. Let me rewrite that. Then we can use the Pythagorean theorem that the 2 side lengths squared and added together would be equal to this hypotenuse squared. We can say that 3 squared plus 11 squared is equal to that distance squared. And we would find this exact same equation if we labeled these. Let's say this is x1, this is y1, and this is x2, and this is y2. Then we can just plug in these values, simplify everything, and after we, let's say, square root both sides of this equation, then they would look identical. So either approach is completely valid, but this approach with constructing a picture gives us a more visual interpretation of what's happening. But admittedly, this formula, if you do know it, is much faster than drawing a picture. But we have this equation. Let's now simplify it. 3 squared is 9. 11 squared is 121. And adding these together, we get 130 is equal to d squared. Now let's take a square root of each side so that our distance is the square root of 130. And I do want to mention, usually we would put plus or minus here, but since we are dealing with a physical distance, we are just concerned with the positive case here. And we could try to simplify this square root, but in this case, it does not simplify. We cannot break 130 down into any perfect squares as its prime factors. But if we do want this as a decimal, we can approximate it since it is irrational. This will be approximately equal to 11.40175 and so on, or we can just say approximately 11.4 units between these 2 points.